Hello, welcome to the 11.1 video on surface area and volume. The chapter surface area and volume, the section is circumference and arc length. Circumference should be an old topic that you've learned about before, but arc length will certainly be new. So, to start with, we really need to know what pi is. And we haven't really talked about pi that much. We missed out on pi day. But pi is going to be easiest put as the ratio. Let's see how this pen works. Yeah, that's fine. The ratio of a circle's circumference to its diameter. No apostrophe there. That's my bad. Okay. You probably have not learned it that way. You probably learned that pi is approximately 3.14 and so on. Little wavy things here. Okay, that's likely how you learned it. But pi is what comes up when you take a circumference and you divide it by the diameter, and we'll see that very soon here in the circumference formula. Okay. But we'll use 3.14 for this class. Remember, pi is an irrational number. It goes on forever. It never ends. It's a Greek letter. It looks like this. Okay, so we'll talk about that a lot today. For our class, though, this year, we'll go ahead and use this approximation. Let's put a little arrow. Use this approximation. There are certainly other approximations. There's 23/7 and 22/7. But ideally we would just use pi. It's the most exact one. Okay, let's get started though. Circumference of a circle, you should have learned this before. Okay, simply put, the circumference of a circle is pi times diameter. Okay, so it's pi times diameter or 2 pi r. Okay, so we'll put both of those. So we'll put pi d and 2 pi r. Now, the reason that they both work is that the diameter of a circle is just 2 times the radius, right? If you look at the diameters all the way across, this would be a radius and this would be a radius as well, which is why we get this 2r pi, or pi times diameter. Okay? This is where the definition of pi comes from. If you divided this by d on both sides, we would get pi equals circumference over diameter, and we'd be done. Okay, so we'll be using this formula a lot today. Okay, and there's a couple more we're going to use, but make sure you have that one marked down. Try to put big boxes around it this time so you can see it. Okay. Let's do 3 examples. Find the circumference of a circle with a radius of 11 meters. So again, circumference, the 2 formulas are pi times diameter or 2 pi r. Okay. So we have a radius of 11 meters. We have a radius, and so we want to use this one right here. So we want circumference is 2 pi r, but we know the radius, which is r, is 11 meters. So put an 11 in there. And so our circumference is 2 times 11 is 22 pi. If you plug it into a calculator using 3.14, see what you get. 22 times 3.14, you get 69.08, so we'll put 0.1. Okay? That would be the circumference. Again, that's meters. Remember, circumference is just all the way around the circle. Okay? Let me put that up here in case you forgot that. I'm going to put all the way around the circle. Alright. So not too bad here. This would be the ideal answer, 22 pi. But if that makes you nervous, go ahead and find the decimal. Okay? Number 2, find the diameter of a circle with a circumference of 18 yards. Again, we want diameter, so we want to use the diameter formula, so pi times diameter. So we have circumference equals pi times diameter. So we have circumference, which is 18, equals pi times diameter. Now to get diameter alone, we simply divide by pi on both sides. Pi is just a number. Cancels over here. And we get d equals 18 over pi. And that's completely fine. Take 18 divided by 3.14, and you will get a diameter of 5.73. So we'll put 5.7. And we'll put yards there. Okay? Simple enough. Dividing by pi was the important step here. Make sure you're comfortable doing that. It shouldn't be too scary. Alright, number 3. Find the exact measure of the radius of a circle where the circumference, that's what C is, right? The circumference is 120 feet. So again, we have C equals 2 pi r. We want to use the radius one, that's r. This was d. So we have circumference equals 2 pi times the radius, which we don't know. Okay? Step 1, you can divide by 2 on both sides. Let's go ahead and show that step. We get 60 equals pi r. Then to get r alone, we need to only divide by pi. So divide by pi on both sides, and we get r equals 60 divided by pi. 3.14 is what we're going to use. And we get 19.1. That would be feet. Okay, so that should have been review, nothing too terribly difficult, just working with these formulas right here. Obviously, if you wanted to only know pi times diameter, for example, if they said find the radius, you would just need to find half the diameter. The relationship between the diameter and the radius is very important there. All right, on to the important part for today. It is arc measure and arc length. Okay, now we have learned arc measure before. That's this is a recall thing, right? That's what this means, recall. Okay, so if you're looking at this circle, we have a central angle of 110. Let me zoom in just a little bit here. If I actually push zoom, it doesn't record, so we're going to try to put the camera closer to the table. Okay, the central angle is 110, and so remember this arc here from A to B, that arc has a measure of 110 degrees, okay? That's all well and good, but that's not interesting. If I wanted to know how far I've walked around the circle, if I go from A to B, this will not tell you that. That just simply tells you the measure of this angle, which is how we defined it. So arc measure is the measure of this arc in angles, right? Like we talked about that this arc measure is the same as this angle. Where arc length is going to be literally how far from here to here is it if I walked across that circle. And so we're going to find the formula to find that piece of information today, okay? So, arc length. It says that the ratio of the length of a given arc to the circumference is equal to the measure of the arc to 360. So the portion of the circle out of the whole circle is the portion of the arc out of the whole arc, if that makes sense. That's the proportion that we would set up. Sometimes you want to use this proportion to solve problems. I'm usually going to try to use this formula right here, okay? So it's going to be the arc length of the certain arc, so from A to B here, is going to be the measure of the arc as far as that angle goes, right? That arc measure, divided by 360. That'll give you the portion of the circle, multiplied by 2 pi r. Remember, this piece right here is simply the circumference, okay? So this is the same formula as this. Actually, if you look right here, you took this arc length times 2 pi r on both sides, you get this formula right here. I'm going to try to use this bottom one. You can use whatever one you want, okay? So let's go ahead and try to solve some of these problems. So we want to find the arc length from A to B, so the distance from A to B. Remember the formula, we'll put arc length of AB is going to be the measure of AB over 360 times 2 pi r. Now, the measure of AB is congruent to the number here, the central angle, so it's going to be 88 out of 360 multiplied by 2 pi r. So we have 2 times pi times the radius, which is 2. So on top, well, we have 2 times 88. So we have 352 out of 360 times pi. So let's use 3.14 again. And we end up with 3.070. Okay? So put 3.1, that'll be in meters. Again, this is just a portion of the circumference. It's not squared or anything. So that arc length is going to be 3.1 meters. So again, we took the measure of the arc as far as the central angle goes, divided by 360, multiplied by the circumference, which is 2 pi r in this case. Okay? So again, not too terribly difficult. We'll work with it a little bit more. Number 5 here. Find the measure of arc RS if the radius is 12.3 feet. Okay, so notice here, it wants the measure. We already have the arc length, so we want the measure. So we want to know the measure of this angle, RQS, or just the arc, RS. And so we know that the formula for arc length of RS is the measure of arc RS, which is what we want, right? This whole thing is going to be abbreviated as measure of RS. So it's a measure of RS divided by 360 multiplied by the circumference, okay? which is 2 pi r. But r is 12.3. Now, I did make a mistake here. I wrote arc length of rs, but we already know what that is. It says right here it's 38 feet. So now we have an equation. We have 38 equals the measure of rs, which is what we want, out of 360, multiplied by 2 pi times 12.3. Okay? Not the friendliest equation to solve, but not impossible. To start with, I would multiply by 360. So take 38 times 360, and you get a big number. Okay? Make sure I didn't type the wrong numbers in. That seems large. Nope, that's what it is. 13,680 is the measure of arc rs times 2 pi times 12.3. Okay? And now we can just divide by all of this. This is just a number, right? So we'll take 13,680. Well, let's take 2 times 3.14 times 12.3. That's 77.24. And we'll take 13,680 divided by 77.24. And we will get that the measure of arc rs is equal to 177.1. Okay? That would be in degrees. Which looks about right as far as the picture goes. Again, you never want to trust pictures in geometry, but it's about half a circle, right? Okay, so that's just using the arc length formula and manipulating it a little bit to get what we want out of it. Okay? On to number 6. This one wants us to find the arc length. Okay, so this is another practice problem. Again, same formula. The arc length that we're looking for, let's put arc length of AB is going to be the measure of this arc right here, which is 97 out of 360, again using the same formula, times the circumference, which is 2 pi r, which is 4. This is an easy one. We just plug all these things into the calculator. We take 97 divided by 360 times 2 times 3.14, which is pi, times 4. And we would get 6.76. Whoop! Camera fell. A little bit unbalanced there, sorry. So we'll put 6.8 feet, it looks like here. That would be our arc length. Okay? And on to our last one for today. With word problem. It says a conveyor belt for luggage at an airport is shown at the right. The outer part of the belt forms a 180-degree arc at each end. For each arc, the radius is 8 feet. Okay, so notice there's a little circle at the end here, right? Approximate the distance around the belt for a coin on the outer portion, round to the nearest foot. Okay, I don't know why it says coin. That's interesting. But it feels like it's luggage, and then they got lost and put coin. But either way, if we have something going around the luggage thing, we kind of have a circle and a circle here, right? And we know that this outer part is 20 feet. And so all we really need to know is how far is it from here to here, right? All the way, that part of the circle, okay? Because if we know what that is, then we can go ahead and do both of these, right? Because we know that this half of the circle right here, we can do 20 feet on both sides, 20 feet, 20 feet, and then the portion of this arc and the portion of that arc, and we'd be good to go. Okay? And so let's go ahead and do that. We're going to ignore the words here because, like, it says each arc the radius is 8 feet, but this one's 8 and this one's 4. And so we're going to pretend. Is that what it meant to do? Oh no, it totally is right. Okay, so this whole thing is 8. This is 4. I'm not sure if that's super important, but let's go ahead and go through it. So we have 8 feet here. We again need this outside. So what we need is this angle right here. We know the radius, and again, the arc length formula is the measure of the arc. I'm going to put measure of arc over 360 times the circumference, 2 pi r. Okay, in this case is 8. So this piece right here is half a circle. It's going to be 180. It says it right here. It forms a 180-degree arc. So for this arc, we'll call, or this half circle, we'll call it A, and we'll call this one B. If we want to find the measure of the outside here, we would do the measure of the arc, 180 out of 360 times 2 pi, and then 8 is our radius. Okay? 2 pi times 8. Now this would be, what is it? 1/2 times 2, so this would be 8 pi total. And that number, 8 times 3.14 is 25.12. That is just for, this is for A. Okay? Now B is also going to have a radius of 8. Now it says 4 to here. That's not even important, right? This whole thing's going to be 8. And so B is going to have the exact same size, right? And so far we have 25.12, 25.12, 20, and 20. So to get our total distance around the outside, as long as I'm reading this correctly, we would have 25.12 plus 25.12 plus 20 plus 20, which would be, what is that, 40, and this is 50, so 90.24 feet would be our total approximate distance. Okay, nearest foot, so we'll put 90 feet. Okay, that is the end of section 11.1. Go ahead and watch the next video after this, but have a good day.